Well, hello everyone and welcome back to Digital++. In the previous two videos, we built a vendor-agnostic multiplayer XR application. And the key item of a metaverse that we want to build is that the user experience is immersive. But what good is a metaverse if you cannot hear each other, right? So in this video, we will add voice services to our application. If you haven't watched part 1 and 2, and you're building your own multiplayer application, you should be fine to follow right along. As in the two previous parts, I will start with a little bit of research and design. If you don't want to wait for that and jump right into it, fast forward for about 3 to 4 minutes and we'll meet you there. Now, let's roll up our sleeves and get into the weeds. So in part 1 and 2, we talked about the design of the network. And we decided that the avatar would be networked and the more complicated XR rig would merely locally control the avatar. Now, if you want to add voice services to this environment, there's two ways you can implement that. The first way is option 1, which you call local. You use the netcode for game objects and you channel your voice, audio, and traffic over the netcode for game objects layer. That's option 1. Obviously, you need a product that supports that. The option 2 is that you build a parallel network that implements the voice services. So once the avatar is spawned and set up, you make a separate connection to the voice network, which is cloud-based. The con side of that, you need a cloud account, you need to register in the cloud, and there's costs involved for cloud services. But the pro side is that the cloud provider makes sure that you don't need to manage all the voice traffic yourself. So our preferred solution here is this option 2. And I'm going to tell you why that is in the next slide. So there are a number of voice solutions available on the market. I've identified 4, and there's obviously many more. These are the 4 ones that I found. Number 1 is Vivox. Vivox is very tightly integrated with Unity in such a way even that you don't need to register separately. So you can enable the Vivox service on the Unity homepage, and you need an account for Unity anyway to be able to start even as a home user. So on that dashboard, you can enable Vivox. Vivox is a cloud-based solution, and there's a cost to it, but only if you exceed 5,000 concurrent voice users, which I think in the metaverse would be ridiculous. That probably will overload the CPU of the device. The other solution is Agora, which I think is the most exciting one of all so far that I've seen. It's also cloud-based, and it doesn't only do voice, it also does video, and it allows for streaming of your desktop. It's a paid service, but only if you exceed the 10,000 minutes per month. A third one is from a guy called Adranek, and the product was called Univoice. It's for free, and the comments here are that it is voice only. There's very little documentation, so I didn't want to go into a rat hole and try that out for now. But maybe there are people that have tried this and maybe it works. The last one I found was Dissonance. That's also a local hosting model, so that will run on top of netcode for game objects. It's voice only as far as I could see, but there's a cost to it. It's about 80 to 90 euros or dollars, depending on where you are. So you see the preferred mark there, and the reason why I want to go for Vivox for now is because it is very tightly integrated with Unity. So having said that, let's go to our next. So a little bit of design before we start our building and coding work. If you watch part 1 and 2, you've seen that we built a UI, and we now want to add a checkbox to our UI that enables the voice service when we start our environment. And why is that? Because when the voice services are implemented and you start adding more features and more new things to your metaverse, then you don't want to necessarily always do the voice testing, right? So it would be just convenient to have an option to just turn that off. We connect to our voice service after we sign in as a host or a client. That means we wait until our avatar is there, and then we start voice. It doesn't really make sense to have already an audio channel when your avatar hasn't shown up yet, right? That could cause confusion. The next thing is that we only need one voice channel in our application. You may want to build more in the future in your particular application, but at the moment we will need only one. You could call it whatever you want. Vivox also has an option to do text chat, but we will not implement it at this phase. If available, we want the audio to be positional or spatial. That's a big immersive thing that I think is important, and we want to see if we can implement that as well. And finally, the C# script to sign into Vivox and to join the voice channel must be a component of the network manager. The reason for that is that to join a voice channel, you need to join with a name, and that name will be the name of your network identity, and you can pull that from the network manager. All right, having said that, we've done our design. Let's roll up our sleeves and start building. Okay, so the first thing we want to do is we want to open unity.com, and we go to the dashboard. We sign in, and I'm going to click here and create a new project. We'll make sure the name is exactly the same as the name of the project we developed in the first two parts. So build a Metaverse test. Create project. So now that has been created. Let's go back to Unity and we go to edit project settings. Use an existing Unity project ID. Oops. Select project and we just select the project that we just created. And now we do link project ID. So that's done. Now, if you go back to the unity.com dashboard, under multiplayer, under Vivox, the voice and text chat, you see that's very tightly integrated. And let's click on this button. And we want to have Unity, obviously. And we can now see the credentials part here. You will see four things: server, domain, token issuer, and token key. Remember these, please, because we'll need these when we start setting up the voice services in our application. So we'll have to come back to this dashboard. So minimize this for now. So we will go to Window, Package Manager, and then we'll do packages in the Unity registry, plus add package by name. And we type com.unity.services.vivox. We'll hold the video here and come back when it's done. Okay. So that is now installed. If you open it up, we can see it is currently installed. Make sure you install version 15.1.21 plus, because as per August 1st, 2023, the older versions are no longer properly working. So let's make sure you do that. There's a samples here, and you can import it if you want. Let's do it now. There we go. All done. Now, if you go into File, Project Settings, and then Vivox, you see that the server, the domain, the token issuer, and the token key are already linked. Make sure you click the Test Mode button here. For testing, we can switch it on. So that is done. Now we need to install another package. Because we are using Android, we want to make sure that we have the authentication for Android properly installed. So we go to Package Manager and we type in authentication. There you go. And we'll update it to version 2.6.1. Okay, that is all completed. Our packages are now installed, and let's start building our voice integration. The first thing we want to do is create an empty game object, and we call that VivoxVoiceManager. We now add a component, and we call it VivoxVoiceManager. Now you see that you again need to enter your key, your issuer, domain, and your server here. So let's make sure we add those in. So we go back to our Unity dashboard. Let's copy paste that over there. Note that the order in the dashboard is not the same as the order in this script here. So be mindful that you need to put them in the right position. Then the domain, we copy paste that there as well. The token issuer is this one. And then the key, which obviously I should not share with you guys, but I'll undo it as soon as this thing is published. is over here. So we have our Vivox Voice Manager, and just to be sure, let's do a quick run, see if we get any error messages, see if everything works as it should. There we go, and it seems to work. So our next step is that we will add a checkbox to our canvas. We go to plus, UI, and we want to add a toggle component. We'll move the toggle component a little bit down. Now with the toggle component, unfortunately, the text is not that great. So let's go to label and delete that, right? And then under the toggle, do a plus UI text mesh pro. So we move that down a little bit so that it fits roughly over there. And the text label we will call join voice services. We want to make font a little bit smaller. So let's make that 24 pixels and then make this field a little bit wider. There we go. And then maybe the text, we want to change the color. So we want to color pick a nice gray color. There we go. Move that a little bit down so that it aligns better to the button. Then let's open up the launch UI code. So first of all, serialize fields. And we'll do it this way. We copy paste that and we say private toggle voice toggle. And then we want to add here a voice toggle dot on value changed dot add listener, and then we say delegate, and we open a Vivox. We call it Vivox toggle voice toggle. I'm not sure what happened here with delegate. Next to awake, we will create a void Vivox toggle, and it has a toggle reference. And the only thing we do at the moment, we do a simple debug.log voice voice toggle dot is on. So what this does is to our launch UI script, we're now adding a handler for the voice toggle. So as soon as something changes on the voice toggle, it'll call the Vivox toggle script, and the only thing that does is a debug log. That's all we need to do in this script. So let's save that. Let's go back to Unity. If you look at the launch UI script, we linked the host button and the client button to our script. So we need to do the same for our toggle. So click on toggle, drag, drop that into our voice toggle field. And now the voice toggle function in our script is connected to our UI. Then we now obviously want to make sure that our toggle is also reacting to our XR rays. So we want to add here a graphic raycaster component, and we want to add a tracked device graphic raycaster. So this way our toggle will also respond to actions that we do with our controllers. And what we can do is we can open the app, and if we click our join, you actually see that it's now off, voice false. If we click it on again, you see that the voice is true. Okay, so now that the Vivox Voice Manager has been defined, I'm going to add a new component to the network manager, and that is a script called Vivox Player. So it's a new script. Let's create it. The Vivox Player will join to the Vivox service, and it will sign into the voice channel. So let's open that up first. And then why do we want to do that in the network manager and not in the Vivox Voice Manager, or maybe in the avatar? We want it in the network manager because you need to sign in with a unique name, and the unique name is the name of the network participant. So that way, if we make it a part of the network manager, we can access that name. First things first, let's start with defining a couple of variables that we need in our class. So first of all, we want to have a private Vivox Voice Manager, call it a VVM. Then we want to have an iChannel session, and it doesn't recognize that. So let's look at potential fixes using Vivox Unity. So we want to have a variable that links to the channel where we've actually have signed in. Then we want to have an integer that we need for getting permission. So I'll come back to that in a second. And then we want to have a field there where we can enter the voice channel name. And that needs to be public because you want to change that in the Unity console. So we say public string voice channel name. You can pick here whatever you want. Then in the start function, we want to initialize our VVMs is VivoxVoiceManager.instance. We want to now add two functions on user logged in event. And we want to add here a function called on user logged in. That doesn't exist yet, so ignore the warning for now. Then on a user logged out event, and we want to add here an on a user logged out. So let's define these two functions. Void on user logged in. There we go. And then we create a void on user logged out. Then we're going to create a new function which we call public void sign into Vivox, no parameters. And what it does, it first implements a number of mandatory permission functions for Android. And I'm going to copy paste that in. If you want to have that, you can either go to your samples or you can find this file, the Vivox Player.c# on my GitHub and download it there and copy paste it from there, because it's a lot of mandatory code which I didn't come up with myself, which needs to be implemented in this function. So it adds a function that checks whether or not you have Android 12. It checks if you have permission granted to use your microphone. It has a function that asks for permission, and if what happens if permission is denied. So the first thing we want to do there is check is mic permission granted. Then we want to sign into the VivoxVoiceManager. But with what name are we going to log in? Well, we're going to log in with the network name. We can now use transform.name.toString. And this is, by the way, a function, so I need to have two things there. If this is not granted, and it says then if permission denied, permission asked count is 0, vvm.login transform.name. If we don't get permissions, we will try to sign in. If there's no permission denied, then we will ask for permissions. And I see permission here, so I need to add some fixes. Permissions is a function that is called in Unity engine.android. So let's add that to our using at the top. And then we now want to start implementing the code for when a user is logged in. So what do we need to do there now? So first of all, we do a debug.log and we say successfully connected to Vivox, right? So we know that we have signed in. And now we can also do a debug.log joining voice channel, and we'll add our voice channel name. So now we know at least in our debug log that we're joining the right voice channel. Now we are going to do a join channel, and we are going to join the voice channel name because we need to have that. We are going to do a channel type dot non-positional, and remember in our design we said we wanted positional, but we're going to do that in a later step. And we want to look at the Vivox Voice Manager dot audio only. We're not interested in doing it a text yet. Okay, and what I also need to make sure that I only do this if I'm already logged in, right? If I for whatever reason would not be logged in, just to be sure, I want to add another check. So if vvm.login state is Vivox Unity dot login state dot logged in, then we execute this code, and else we provide a nice debug message. So debug.log cannot sign into Vivox. Check your credentials and token settings. Now we also need to handle the logged out, and for we first want to do a debug.log, and we say disconnecting from voice channel plus voice channel name. Then we do an underscore vvm dot disconnect all channels. Then once we are signed off the voice channel, we are now going to sign out of Vivox. So let's do a debug log disconnecting from a Vivox, and then we do an underscore VVM logout. So that is all completed. And that should be it. So let's give it a try and see if we can make this work. All right, so now we have completed our code. We can run and do our first test run of the application. So what we'll need to do is run our laptop in host mode, and we also want to load the application into our virtual reality glasses. So for that, it's running on this device. I'll start up this laptop as a host. What I will now do is switch off my microphone and move it away, and then you should be hearing me coming in using the audio of my virtual reality glasses. So switch off the mic. So you now hear me coming in over my virtual reality microphone as the remote participant. Let me make sure that I will move in front of the camera. Here you go. I'm here. Hello. So I'm speaking here now with audio, but if I move around, there is no positional audio yet, right? So if I move in front or left or right of the host, then you still hear me with the same amount of volume and from the same direction, which is always unidirectional. And now for the final stretch, we want to change the non-positional audio into positional audio. If we go to our script, so let's double click on our script. In the onUser logged in function, there's a call to join channel. And that is called with a channel type of non-position. So let's uncomment this and copy paste that. And then we want to change that to channel type dot positional. Great. Now, unfortunately, that's not all, because we need to feed the VivoxVoiceManager platform with the location of your avatar. And the location you provide by a call to the channel that you've signed into. Well, we've called VVM join channel here, but we unfortunately do not have a direct link to the channel yet. So we'll start do that first. Go to the top here and add an additional variable, private transform XRCam. This will hold the position of our XR camera, because that's the position that we need to provide to the platform. In the start function, we can then add a XRCam is the game object dot find main camera. And we need to have the transform and not the object itself, because we want to know the location. The next thing we want to do is on user logged in function. Once we've joined the channel, we now need to get a channel ID. So we introduce a new variable called CID, is new channel voice channel name, and then channel type dot positional. If you get an error message and it doesn't recognize channel, again, do the same. You hover over and you use the suggestion to add another library in the using part. And now we need to identify what our channel pointer is, and that is the vvm.login session.get channel session, and then we enter the CID. Okay, good. So now we go to our update function, because in the update function, this is where we will provide the system with positional audio. The thing we need to call here is a underscore chan dot set 3D position, and you need to provide that with the position of where your mouth is, the speaker pause, the position where your ears are, so that's listener pause, the direction where your camera is pointed to, and what your up direction is. Let's enter these. So we have our xrcam dot position, we have our xrcam dot position. In our situation, we're going to take the position of the head, of the ear and the mouth in exactly the same place. There's no need to make those different. xrcam.forward, because this is the forward direction of our camera, and we have the xrcam.up. Now we can run this and it'll work. However, every single update cycle will pass on the 3D position to the cloud, and that's very intensive for the network and also very intensive for our VR system. So we do a little bit of code here to limit the amount of traffic. So let's introduce a float and we'll call it underscore next update, and we'll make that 0. We also want to, oops, I made a typo there. We also want to see if there is no channel. So if underscore channel is as null, then we want to return. Then if the channel state dot toString, if that is connected, we do another if, and then we look at our time, and if time is bigger than underscore next update, then underscore next update. So let's copy paste that over, paste that in here, and now we want to update 0.5f. You could also do this elegantly, make this a serializable parameter that you can change in the Unity dashboard. We're just going to hard code it now. That means every half second we will provide an update of a position of our audio. So let's see if we can save this, and then we will go back to Unity, see if it compiles, and let's try and make this run. So the application has now been compiled and installed in the VR system, and it is up and running here now. Let me see. And I'll start my PC as a host, and then I will mute my microphone here, so you should be hearing me coming in over the network from my VR glasses. First I'll start the application as a host, and I'll go on mute. I think you can hear me now. So I'll move in front of the avatar. There we go. You hear a little bit of echo because I have my laptop turned on. So if I move to the left now, you should hear my voice changing direction, and I'm actually should be standing on your right. And the audio should be fainter the farther away I go away from you. So you should be hearing less and less, right? And the closer I come, so I'll now come closer back. I'll move back in closer to you. Hello, hello. There's the audio, almost down the middle. And now I move to the right, my right. So your audio should be now hearing on the left. And the further away I get, the less you hear. Okay, so I'm now coming close behind you. And let's turn around. There we go. So that completes our tutorial. And that wraps it up for this episode 3 of Building a Metaverse. We have extended our multiplayer XR rig that we developed in part 1 and 2, and we added voice services. Initially with non-directional and non-positional audio, and later on we added positional audio, which should really be a much better user experience. Thanks very much for watching, everybody. Really appreciate it, and hope to see you soon. Bye bye.